Hello everyone. So in this video we'll take a look at how we can actually perform the prediction using the fundamentals of the Bayes theorem. So basically the probability of y value that we'll calculate over here, this y value basically will take positive and negative, that is we'll try for both the class labels. Okay, so what is the probability that the result is positive given, let's say, x1, x2, x3 and x4 values, and what is the probability that the outcome is negative given the x1, x2, x3 and x4 values. Let's say if there are 4 features. So if this is greater, we'll predict that the label will be positive. Okay, and if this is greater, we'll predict that the outcome is negative, that is the prediction will be negative. Okay, so now let's start with an example which is like the hello world example of data mining and machine learning. Okay, basically we want to predict whether we can go out to play tennis, and that is dependent on 4 features or 4 attributes or 4 variables. Basically, first is how does the sky look? Is the sky sunny, overcast, is it raining, etc. How is the temperature, how is the humidity, and whether it is windy or not. Based on that, we'll either classify the situation to be worth or suitable for playing tennis or not. Okay, so this is our given data set, you can call this. Okay, these are the data values, training data you can call it. Okay, so now basically these are the records. Like for example, when like let's say some club clerk at the club or somewhere, they have maintained a written record. Like for example, when the sky was sunny, temperature was hot and humidity was high, and it was not windy, but still because the temperature was high and humidity was high, let's say the game was not played, or they did not play tennis. Whereas when it was overcast, hot, humidity was high and it was not windy, but still they went out to play tennis. So it's kind of a record that we have, a training data, and based on that we want to make a prediction. So now what we do is we create some kind of a table for each attribute. Okay, so basically if we talk in terms of x and y, this is x1, this is x2, this is x3, this is x4, and this is y. Okay, so now what we'll calculate is we'll first make a table for x1, that is the outlook. Okay, now what will be the rows and columns? Okay, so this will be the table. Okay, and rows will be, it depends on how many values that particular attribute has. So in this case, by observation I can see that there are 3 possible values, either sunny, or it is overcast, or it is rain. Okay, and in terms of columns, I have only 2 outcomes, either positive, that is plays tennis, or negative, does not play tennis. Okay, so first I'll count how many times is it the case that it's sunny and the class is P. Okay, sunny and P. Okay, so if I count, there is only 2 times the case that it is sunny and the outcome is P, and it's 3 times that the outcome is N when it is sunny. Similarly for overcast, if I see, it's 4 and this is 0, and rain and P. Okay, when outlook is rain, how many times is the outcome P? And the outlook is rain P1, rain P2, rain P3. Okay, so it's thrice, and it's twice that it is N. Okay, now take the sum of the column. So here the sum is 9 and here the sum is 5. Now this is called as the frequency table. Okay, now for simplicity what I will do is, here itself I will calculate the likelihood table basically. Okay, so now I calculated the sum over here, 9. So basically if I say 2 by 9, 4 by 9, 3 by 9, these are the likelihood values. Okay, so this is the probability that it is raining given that the person goes out to play. So basically I have restricted my sample space only to the P outcomes. Okay. Similarly in this case it is 3 by 5, 0 by 5 and 2 by 5. I have restricted my sample space to only the does not go out to play. So only 5. Out of those 5, what is the probability that it is sunny? It is 3 by 5. And what is the probability that it is raining? It is 2 by 5. Okay, I hope this table is clear to you. Then similarly, we will calculate the other two tables, other three tables in fact, because we have four variables. Okay, so I'll repeat this process for humidity. Okay, humidity, there are only two outcomes, or there are two values for this particular variable. Sorry, not value, high and normal. There are two values, high and normal, and again the columns will again be the same, P and N. And here is our 2 by 2 table. So here we have, if you count, humidity is high and P, it is 1, 2 and 3. So it's thrice the case that it's similarly 4 times the case that it is high and does not play. Okay, high and does not play. It's normal and plays 6 times. If you count, you can pause and count for yourself and verify. And 1 times it is normal but still does not go out to play. And then we'll calculate the likelihood. So we'll first calculate the sum. This is 9, this is 5. Okay, and then you will say that this is 3 by 9, 6 by 9 in the restricted sample space. The probability that the humidity is high given that the person goes out to play is 3 by 9. Probability that the humidity is normal given that the person goes out to play is 6 by 9. Probability that the humidity is high given the person does not go out to play is 4 by 5. And probability that the humidity is normal given the person does not go out to play is 1 by 5. Okay, now let's next go to the next variable. Next variable is temperature. Temperature has 3 levels or 3 possible values, that is hot, cold and mild. This is P and this is N. Okay, so again hot and P combination will occur twice if you count. Hot and N combination will occur twice. Cold and P combination occurs, cold and P combination occurs 3 times, and cold and N combination occurs only 1 times. Mild and P combination occurs 4 times, and mild and N combination occurs twice. Okay, and if you calculate the sum over here, it's 9. If you calculate the sum over here, it's 5. And then you calculate in this way. So this is 2 by 9, 3 by 9, 4 by 9, and this is 2 by 5, 1 by 5, 2 by 5. Probability that the temperature is hot given that the person goes out to play is 2 by 9. And just one more value for to make you understand. Probability that the temperature is mild given the person does not go out to play is 2 by 5. Okay, then the final table is the windy table, the windy attribute, whether it's windy true or windy false. Okay, and P and N. So combination of windy being true and the outcome being P occurs 3 times. Combination of windy being true and the outcome being N occurs 3 times. Combination of windy being false and outcome being P is 6 times, and windy false and outcome N is 2 times. Take the sum, this is 9. Take the sum, this is 5. In fact, the sum of the column P will always be 9 and sum of the column N will always be 5. Okay, so you can verify that as well. Okay, and now this will be 3 by 9, 6 by 9, 3 by 5 and 2 by 5. So probability that it is windy given that the person goes out to play is 3 by 9, and probability that it is not windy given that the person does not go out to play is 2 by 5. Just to make you understand or interpret this table. Okay, so now we have all these probability values. Okay, Now what do we want to actually calculate? Okay, so let's say we are given, we want to predict. Now this is the background work that we did. Okay, given the training data set, even if you don't know what this is your training phase, I can say this is your training phase. Okay, now what will you actually do? The testing or the application or the actual prediction that you will do is, we need not even look at the original table now. Whatever we'll write will be only based on this now. Okay, now one more observation, one more thing that we'll need is, what is the probability of P and probability of N? So if you calculate, there are total 14 rows in this. Out of those 14, 9 of them are P and 5 of them are N. So therefore, if I say the probability, okay, I'll calculate here. The probability of P, okay, probability of P is 9 by 14 and probability of N is 5 by 14.